Hello to all, I am Dr. Alkesh Agrawal, and in this lecture, I'll mainly discuss how to convert the mod value of a given ripple counter. These are some reference books that include Digital Design, authored by M. Morris Mano and M.D. Saletti, and Modern Digital Electronics by R.P. Jain. So, in my previous lecture, I discussed in detail about asynchronous counters, which are also known as ripple counters and frequency divider circuits. So, here is one of the configuration in which we have three stages of JK flip-flop which are working in toggle condition. The negative edge triggered clock is used to activate a particular flip-flop. The stage to which we directly give the master clock is the LSB stage. So Q0 is the LSB bit and Q2 is the MSB bit. Q1 is the middle bit. Then we can see the normal output is triggering the clock of the second stage, and the normal output of the second stage is triggering the clock of the third stage. So in this slide, I have shown you that this is a mod 8 triple up counter. Why up counter? Because at the negative edges of the master clock, Q0 is toggled from 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1. Then Q0 is acting as clock pulse for Q1. So with every negative edge of Q0, Q1 is toggling. So at this negative edge, Q1, which is initially at 0, toggle from 0 to 1, remained at 1. Again, at the second negative edge, Q1 output toggle from 1 to 0, remained at 0 state. Then at the next negative edge, Q1 toggle from 0 to 1 state, and so on. Similarly, Q1 output act as a clock pulse to trigger Q2. So Q2 initially remained at 0 state until and unless the negative edge of Q1 is encountered. So at the negative edge of Q1, Q2 toggle from 0 to 1 state. And so we have this count state as all zeros and 001, 010, 011, 100, 101, 110, 111 back to 000. So we can see that it's a mod 8 ripple up counter. Now important thing is how we can convert the mod 8 ripple counter into different mod valued counters. So here we can see, suppose we want to convert mod 8 counter to mod 7 counter. So what is the basic idea or principle behind this is, so the counter will traverse from 000 to 001, 010, 011, 100, 101 and 110. The moment the counter, now from 110 it has to directly go to 000. So what is the idea behind this is, the moment the counter switches from 110 to 111, so this 11 will be the unstable state and it will not be stabilized at this state and likely goes to 000. So like this, from 110 the counter will appear that it will switch from 110 to 000. So what is uniqueness in this 111 is, here all the bits are 1 for the first time, or you can see all the bit patterns. This is the only state where all the bits are 1. So we exploit this condition. So we can see over here is, this is the mod 8 ripple up counter. So what we have done, we have connected the output Q2, Q1 and Q0 to a NAND gate, because we know that in NAND gate, when all the inputs are 1 or high, the output is 0. So the moment Q2, the moment the counter 1 switches from 110 to 111, at the same moment this NAND gate output will be 0 and it will clear all the stages of the JK flip-flop and it will directly go to 000 as shown. So from 110 it will go to 000, because 111 will be the unstable state. The moment the counter enters 111, this NAND gate will be activated, will clear all the states, and Q0, Q1, Q2 will all be in cleared state. So like this we can very easily convert a mod 8 counter into mod 7 counter. Now I have tabulated the pattern. So I have already discussed, in mod 7 we have to skip 111, and what is uniqueness in this is, all bits are 1 for the first time. If we see this pattern, we want to convert it into mod 6 counter, then we have to escape these two states. So from 101, the counter must directly go to 000. So we exploit the bit conditions of 110, because here we can see in 110 q1 and q2 are 1 for the first time. You can see these are 0000001011010, but here both bits are 1 1. So for this output, what we'll do, we will connect a NAND gate for this q1 and q2. So this is the condition that we exploit in mod 5. What happens in mod 5? Our counter will start from this state 00. It will go to this. So this is 1 2 3 4 5, and from 100 it will directly go to 000. So we exploit the bit conditions of 101. Here you can see, here what is uniqueness is q0 and q2 are both 1 for the first time. So we use a NAND gate connecting q0 and q2. Now if we want to convert mod 4 counter, so what will happen, from 0111 it will directly go to 000. So we exploit the condition of this state where q2 is 1 for the first time, because here you can see it is 0 0 0 0. This is 1 for the first time. So we'll connect q2 output to a NAND gate. So like this, I'll show you one by one. We can convert a mod 8 counter into different mod value counters. So here I have shown we have converted a mod 8 counter into mod 6 counter. So what you can see, 1 2 3 4 5 6. So the moment the counter goes from 101 to 110, so this will be unstable state. The counter directly goes from 101 to 000. How? Here I have connected a NAND gate to what? To q2 and q1. So you can see q2 output and q1 output are connected to NAND gate. The moment both these values will be 1, okay, so this output will be 0. It is connected to all the clear inputs. So the moment both these inputs are 1, and output will be 0, and it will clear all the states, and at the moment q0 q1 q2 will all be clear to 0. So from 101, the next state will be 0 0 and 0. So like this, mod 8 counter will be converted into mod 6 counter. Here you can see the mod 8 counter is converted into mod 5 counter. How? So our counter will start from this, it will go to this state, second, third, fourth, fifth. So from here it directly goes to 0 0 0. So what we'll do, the moment the counter switches from 100 to 100, NAND gate will be activated. How? I have connected q2 and q0 to NAND gate, because this is 1, and this will be 1 for the first time in 101. So the moment q2 and q0 will be 1, NAND gate will be activated. It will clear all the this stages of flip flop, and the next state will be q0 is equal to 0, q1 is equal to 0, and q2 is equal to 0. So from 1000, next stable state will be 0 0 0. So like this, it will convert it into a mod 5 counter. Next, you can see how we convert mod 8 counter into mod 4 counter. So our counter will start from this state, it go to this state, this state, this state, and the moment from 0 1 1 it will go to 100. So that will be unstable state. So directly from 0 1 1 it will enter into 0 0 0 state. So how it is possible? Here you can see q2 output is 1 for the first time. Here it is 0 0 0 0, and here it is 1. So this is 1 for the first time. So I have connected q2 output to a NAND gate. The moment q2 is 1 for the first time, NAND gate will be activated as 0. It will clear all the stages of JK flip flop, and the q0, q1, and q2 will all be cleared to 0. So from 0 1 1 directly it will reach 0 0 0. So like this, you have seen that how we can convert a mod 8 counter into different mod valued counters very easily. Thank you.